the first thing you want to do when you're graphing a log is figure out what that little bitty baby number is. You see how this one has a little bitty 2. All right, so because that's a log with a base 2, we will start by making an exponential table for y equals 2 to the power of x. Now, we're not graphing this table. So go ahead, pick up your calculator. We'll do 0, 1, 2, 3. Find those 4 numbers. Again, we're not going to graph it. We're just making our table. So you should know these numbers because I feel like we do this one a lot. 2 to the 0, 2 to the first, 2 times 2. All right, so Isaiah, what you get for your 4 y values? All right, good. Now we're talking about the inverse though. In order to find, so the inverse of y equals 2 to the power of x is y equals log base 2 to the power of x. And remember, whenever you're graphing the inverse, who remembers actually? What do we do with our table when we're graphing the inverse? Flip it. So let's go ahead and do that. So I want you to take all of your x values, put them in your y column. So I'm going to put my 0, 1, 2, 3 here. And then I'm taking all of my y values and I'm putting it in my x column. 1, 2, 4, 8. So let's go ahead and graph this. This is the parent. Remember, the first step is to graph the parent. This is the parent. So let's go ahead and graph that. Put a point at 1, 0, 2, 1, 4, 2, 8, 3. And make sure that when you're drawing that parent that you do not go across that y-axis. See how I'm getting close to it, but I'm not crossing it. So now we're ready to do our transformation. So for a log function, let me just rewrite this. This was on a different page, but it's y equals, and then a comes first, and then it's log, log parentheses x minus, h is on the inside. You still flip h. And then it's plus k on the outside. So the number in front of log, if you don't see a number, that means that it's 1. So whenever a equals 1, it is no change. So a lot of you on the last test put that it was reflected or stretched. When a is 1, we don't do anything with it. H is still inside and you flip it. So somebody besides Isaiah, what would H be? Positive 3. And do you remember what that makes the graph do? Right, 3. Yep. Now in this function, H is the MVP. So it's the most valuable player. Because H tells us a couple of things. It tells me my domain. It also tells me where to draw in my invisible wall. Okay, because this is always x equals h. And the domain is always parentheses, no bracket, h to infinity. So because h is 3, my domain would be parentheses 3 to infinity. And I have an invisible wall at x equals 3. I like to draw that in. It's optional. I'm going to just draw it in so I don't forget about it later. So I'm going to take and draw in a dashed line at x equals 3 so that when I'm graphing my new graph or my transform graph, I don't go through that wall. That's optional. You don't have to do it. But that just makes sure you don't go too far to the left. And the easy part about logs is that your range is all real numbers. And this is always, no matter what, that is going to be your range. Okay? All right, so now we know that h is 3. Can somebody else tell me what k would be? 4. And Renaya, what would that do? Up 4. Okay, so we got my h and k. So now let's go to our parent table. We're going to add the h to x like we always do. And that doesn't matter. That will never change. So we're going to add 3 to all 4 of these numbers. And then we're multiplying. Well, we're multiplying by a. But because a is 1 and it's no change, all we have to do is add k, which is added 4. So go ahead and do that. Get your second or your third table. Again, this table, I'm going to cross it out. Don't graph it. We don't graph the first table. We just make it so we can flip it. And then go ahead and graph it. Make sure you don't go through that red wall. 5, 5, 7, 6. Hopefully I did it right this period. Or first period. I think I messed theirs up, but I'm pretty sure I did yours right this time. Now I'm awake. So I'm going to get really close to that red line. You can kind of like, I mean, you're graphing it. But the main thing I'm looking for, you're graphing it by hand, is that you don't go past it. You cannot go too far to the left. And that is your log graph. All right, what y'all think? Thumbs up, sideways, down, where we at with logs? Pretty much the same. I mean, it's just, you know. Let me see, what do we do after 6? Okay, after this we do triangles. Oh yeah, we only got two more chapters. So yeah. All right, so let's go ahead and review quickly what we talked about yesterday, which is rewriting. So remember, when it's a log, you have the base, the answer, and it always equals your exponent. But I want you to rewrite it in exponential form where you have the base and then your exponent, and that equals the answer. So for this first one, it spells Bae, B-A-E. So when I do my rewrite, it would be 19 to the power of 2. Make sure that looks like an exponent. And that equals 361. All right, take a moment and do 2, 3, and 4. And I'm going to call on 3 different people to help me. All right, Tanya, take a guess on number 2. How would you write that? I would agree. Love, how would you write it for number 3? Perfect. And Jada, what would you do for 4? Perfect. Any questions about how we did our rewrite? All right, now let's go the other way. So we have it in exponential. We're going to write it as a log. All right, so again, base, this is how it's written down, but we have to change it to bay. Log, little bitty number, answer equals E. So for this first one, it would be log. You start by writing the word log. Now it's going to be a little bitty 5. Next is the answer, and it's equal to 0. All right, take a minute and do 2, 3, and 4. Again, with all of these, you should start by writing the word log. All right, so for number 2, it's log little bitty e y equals x. But I want you to know that anytime, so remember, this is the same e that we used when we did PERT, okay? Because it's the same e that we used when we did PERT, this is actually special. Anytime you come across a log with a little bitty e, it changes to a ln, and that ln means natural log. That's what it should be, NL, but they reversed it. If you look on your calculator, everybody look at your calculator, look in that first column. And find the green button and then hop down 2 times. Do you see that button? It looks like an I, but it's an LN. That means natural log. Everybody see the button? All right, so we're going to use that later to solve it, but I wanted you to know what it looked like. All right, so Inma, how would you write number 3? Log with a little bitty what? Okay. Good, and then the last one would be a log little bitty 4, 1/16 equals -2. So that was the first. This is actually what we talked about yesterday. All right, so now let's move on to evaluating. When you're asked to evaluate, what you're doing is finding the exponent. So they don't give it to you. You have to figure out what the exponent would be. So the first thing I like to do is I set it equal to X, but you can set it equal to J for Josepha, T for Tanya. It doesn't matter. All right, I'm going to use X. Actually, I'm going to use G for Gillespie. So I'm going to rewrite it. 3 to the power of G equals 27. All right, don't say it out loud. okay? You need to figure out what this number has to be in order for this to be true. So use your calculator and figure out, what does this number have to be? How many times do we have to multiply 3 to get to 27? Just give me a thumbs up when you know the number. Okay, Bailey, what's the number? 3. So in this example, G equals 3, because 3 to the third is equal to 27. All right, I'm going to use an I for Isaiah. Let's set this one equal to I. So let's rewrite this. 12 to the power of I equals 144. So don't say it out loud. Try to figure out what does I have to be for this to be true? Give me a thumbs up when you know the number. Y'all going fast through these, okay. Joseph, what would you put? 2. Yep. Oops. I always do that. This little thing does not want to stay on my little Apple Pencil. I'm going to have to order some more of these. Okay. I equals 2. Okay. All right. Now I'm going to use a B for Bailey. I'm going to set this one equal to B. Now, when you don't see a number, who remembers from yesterday, what is that number going to be? If it says LN, it would be an E. But if you don't see a number, what's the number? Not 1, close. It's 10. It is 10. So this is log little bitty 10, 1,000 equals B. So this would be 10 to the what power is equal to 1,000? All right, what does that number have to be? 3, good. All right, the last one I'm going to use set it equal to K for Kathy. So we got 5 to the power of K equals 25. So what is the K? What does K have to be? 2. All righty. So now we're going to move on to 6.2. 6.2. Just a reminder, I don't know why I made this due Friday, because you should really be able to turn it in tomorrow, but we'll keep it Friday. But let's move on and start 6.2. So the first thing I want you to do is go ahead and copy this down. We'll see how far we get. So these are the rules that we're using now for 6.2. Put your pencils down when you're done writing so I'll know when you're finished. So there's 3 properties that we're using in section 2 of module 6. The first thing is, we're going to start by expanding it. So anytime we see something that is multiplied, see how this is multiplication is going to change to addition. Okay, so notice how I went from a multiplication symbol to an addition symbol. And then if you see a fraction means division, you're going to change that to, what's the opposite of addition? Nope, addition. Subtraction. Did I say division? Oh, I said, okay. I don't know what I said. But I meant to say, what's the opposite of addition? My bad. And then lastly, whenever you see an exponent, so this is what happens, because a fraction means division, okay? And lastly, whenever you see an exponent, so like you see an exponent right here, we're just going to move it to the front. So we're going to do a few little practice questions today, and we'll pick up here tomorrow. I'm going to go ahead and pass out homework too. So the next thing we have are, what are the steps? So there are 3 different steps that we're going to follow. Whenever we're asked to expand, the first thing you're going to do, go ahead, is you're going to look for a fraction. So the first thing you're going to do is look for a fraction. Then the second property we're going to use is the multiplication. And the last is exponent. what period do you come? 7? Do you want to come like 5th period in your study hall, or do you want to do?
Yeah, I can do it.
5th period? What part of 5th period?
See much.
Okay. All right, so let's go ahead and do a couple practice questions, and then we'll pick up here tomorrow. So again, these are the steps. The first thing I'm going to do is look for subtraction and make it, look for a fraction and make it subtraction. So let's go ahead and look at this first one. So do you notice how we have a fraction? Does everybody see that? So I'm going to separate it with subtraction. So what I'm going to write is log 5y and log x to the 4th. And in between, I'm putting a subtraction. So the numerator got a log and the denominator got a log. All right, what is the next step? Look for what? What did you write down for step 2? Look for multiplication. So do you agree that 5 and y are being multiplied? That's what that means. So because these are being multiplied, we're going to expand that with addition. So now I'm going to break that apart, and it'll be a log 5 and a log y minus log x to the power of 4. Yes, I'm almost finished with this one.
You go ahead and finish.
Okay, so in between the 5 and the y, because they're being multiplied, what did we put in the middle? What did we say? A plus sign. Good job. All right, last thing. Do you see any exponents? Where do you see an exponent? On the x. We're going to move that to the front of its log. So your final answer would be log 5 plus log y minus 4 log x. So what we just did was we took this expression and we expanded it all the way down. All right, I want you to take a couple minutes and try to start number 2. So in number 2, do we see any fractions? So what do we see happening between these 3 terms? What's happening? When you don't see a symbol, it means what? Multiply. And there are 3 things though, okay? We have a 4, we have x squared, and we have y to the 8th. All 3 of those, you're going to put a log little bitty 3 with each one of those terms with an addition sign. Absolutely. All right, so the main thing to keep in mind, and this is our last question for today, is that every time we put a plus sign, we have to carry that log little bitty 3. So I'm going to have 3 log little bitty 3s. I'm going to have a log little bitty 3 of 4 plus a log little bitty 3 of x squared plus a log little bitty 3 y to the 8th. So we already said we did not have a fraction. Okay, so now we separated it with multiplication. We separated the multiplication with addition. The last thing we're going to do Do any of these three terms have exponents? All right, show me with your fingers. How many of them have an exponent? 2. So I'm going to take this 2 and move it right here. This 8 is going to move right there. So my final answer would be log little bitty 3, 4 plus 2 times the log little bitty 3x plus 8 times the log little bitty 3 of y. All right, we are going to pick up here tomorrow. And that is it.